This project is a solar powered clock. It only uses a very small solar panel, so this solar panel can produce 35 milliamps at 5 volts. And I've got it charging some AA batteries, and it will happily run off of that. And it runs off such a small solar panel because the actual circuit itself only takes a couple of milliamps. So all these integrated circuits around the outside and this one up here, they are shift registers, 74HC595. And because they're HC and CMOS powered devices, they only take microamps to actually supply the actual voltage to them. And then I've got a PIC microcontroller in the middle, which is a very basic one. And PIC microcontrollers, when they're in standby or also in low power mode, only take microamps as well. So actually the thing which is taking most of the power on this circuit are the 3 LEDs. And I chose amber LEDs because I don't know if it's just the ones that I've purchased, but these ones give out a decent amount of light when you're only putting 1 milliamp through them. So this circuit is consuming about 2 milliamps, which is why it would last so long on just a simple small solar panel. So the circuit can also be powered through, I've got a couple of supercapacitors. They're only small ones. Actually, to power this circuit overnight, you probably need about 8 of these 10 farad supercapacitors. But this has been charging for a little while, and supercapacitors, they really charge up very quickly. So if I unpowered the clock and then plug it into this into the supercapacitors, it powers just fine off of the supercapacitors, and off of these 2 that I've got in here, it will last about 4 hours. So you really need, for a winter's day where you might not get much light, and the night or the dark hours last more than 12 hours, probably need about 8 of the supercapacitors, but it seems to work fine. So I've got the circuit diagram underneath here, so if I just move this to one side. So this is the circuit diagram. It's very simple. So I've got the microcontroller over here, powered using a 32 kilohertz crystal, that which divides down into exact seconds. It's just got one switch and an LED which indicates the seconds, so that when the minutes and hours aren't moving, you can see that it's still active. You can tell it's not been not frozen, which is quite a nice thing to be able to do. And the switch, its operation is, if you press it, in fact I'll bring it back in, if you press the switch quickly, the minutes go up, or if you hold the switch down and release, the hours go up. So you can actually set the clock fairly easily when you need to. So that's the operation of the switch over here. But the actual operation of the rest of the circuit, like I say, is very simple. So you've got, on each of the shift registers, all of the outputs have LEDs on them, and the shift registers just cascade. So once it's shifted all the bits through one, it will shift them into the next one, and out and into the next one, into the next one. And shift registers have 2 clocks on them, so one which shifts the data through, and one which actually places the data onto a latch on the output. So you can shift the data in without it updating the displays, and then you can put a clock pulse on the latch, and it will put the current data onto the outputs. So the microcontroller decides how far it has to shift the minutes and hours LEDs. So it just puts 2 ones onto the shift registers at appropriate times when it can shift them into the appropriate positions, and it shifts through all of them. So it shifts any data which was in there before for hours and minutes, it shifts out the end, and the new data goes in, and then it will just clock a latch, and it's as simple as that. And as far as keeping the track of the time goes, it divides down one of the timers to exact seconds, and then it increments the seconds in memory, and when the seconds get to 60, it sets them back to 0 and increments the minutes, and then when the minutes get to 60, it increments the hours and sets the minutes back to 0. So it's a very basic project, but I like the fact that it can be powered off of a very small solar panel, and also it can be powered off of supercapacitors, which is really neat as well.